Hey, folks. Thank you. All right, I'm Callum, and we're going to talk about MCP with .NET. So before we get started, a little bit about me. I'm Callum. I'm a Microsoft MVP, a .NET developer by trade. I run a small consultancy out of the UK and Australia called Bump. Hence, I am the chief bumpster, so recruiters cannot find me on the internet. I'm on various platforms at that handle, yeah, today we're going to talk about MCP. So what the hell is MCP? Well, when I was preparing this talk, MCP was a relatively new concept. MCP is a new AI platform, or a new AI protocol that we're going to talk about today. But of course, I did what anyone would do when I heard about MCP, and I went to ChatGPT and I asked it, what is MCP? And it came back with something Minecraft related. If you're expecting Minecraft today, I'm sorry to spoil this for you, you're not going to get anything. Instead, we're talking about AI. So MCP is the Model Context Protocol. This is a new standard, if you will, a de facto standard for connecting AI agents together with tooling. So it's a JSON RPC-based protocol built by Anthropic, and it's kind of been now adopted by everybody. You'll probably have heard of different tech companies saying we now support MCP, we now have an MCP server. And today we're going to look a little bit about what that means in practice, how you would implement this in .NET, but do so in a safe way. Because I think if I told any of our security people that, yeah, we're just going to expose our entire API, our entire system, straight to an LLM and it can do whatever it wants, they would probably have a small breakdown. So today we're going to look a little bit about what MCP is, how it's constructed, how you can then integrate that safely into your existing applications. A couple of key terms that we need to cover before we get started. So when we're talking today about clients, in the context of MCP, a client is responsible for connecting to a host, an MCP server itself. And it's connecting that system with your various MCP servers. So in most common use cases, that would be something like your IDE. Your IDE already has an MCP client baked in, and it's able to connect to a variety of servers. So Visual Studio Code, which we're going to look at today, already has an MCP client, sorry, baked in. Also, like most of the Claude Code and those sorts of desktop apps as well, now also support MCP clients. An MCP server is effectively responsible for providing capabilities. And a server is what is actually doing all of the computation. So we're going to allow an LLM to talk to our server, and the server can then perform tasks and instructions on our behalf. These capabilities come in various different flavors in MCP. Things like tools, prompts, resources, and elicitation. So tools are effectively functions that exist in our server that the MCP client can call on to say, hey, when I ask you to do this task, use this tool or use these series of tools. These are functions. And it builds on functionality that exists in most LLMs called function calling, the ability to execute code effectively on behalf of the LLM. Prompts are ways that you can, as an MCP server, broadcast information to the LLM to say, when your user is interacting with me, these are the kinds of information that they might need, a bit of context, a bit of extra information to help guide the LLM along to making the right decision. Resources are a series of upfront data that the LLM is provided with. And this is helpful if you're building a system that maybe is like a question and answer thing, and you don't want to always call back to the MCP server. You just want to say, this is the information that you might need to know up front. Think of it as like data you're going to include in your base prompt. And then elicitation is this sort of question and answer, collaborative flow. You might want to do this or this, and it might then end up calling a tool or something like that. Today we're going to focus on just two specific areas, the tools and resources. So as I mentioned, tools are functions that we can run on our MCP server that execute code. And the LLM's job is to decide which tool or tools should be called and used. Resources is just broadcasting information. So at its most basic level, this is what an MCP server and client relationship would look like. You'd have your LLM, your model, somewhere in the cloud, most likely. That's your GPT-5s or whatever. Then you have your MCP client sitting in the middle, and that will connect to multiple MCP servers. When a request comes in from a user, the MCP client will delegate that to an LLM, determine, hey, these are the different servers I've got available, these are different tools I've got available. LLM, which things should I call and in what order? And then it will come back with a set of instructions, and the MCP client will execute that against a variety of MCP servers. So MCP servers are not singular in any way, and the tools that they emit and make available are also not singular in any way, so you can build up these quite complex advanced flows. The way that the MCP client and the MCP server communicate is through JSON RPC by default, but also HTTP now. And we're going to look at both of those today because depending on how you're running these, you'll prefer one option over the other. The MCP servers can be hosted in the cloud, and in that case, they'll be communicated with over HTTP, typically. Or they could be hosted locally on your own local machine, and in which case, the JSON RPC approach is quite good. It spins up on a port locally, your MCP client connects to a local port, and it can talk to things on your local machine. This is the sort of journey that happens when an LLM is determining which tools to actually call. So the first process is called tool selection. Well, actually, no. The process starts as soon as your MCP client boots up, and it does a thing called discovery. Discovery is where it will go to all of the available servers and say, hey, tell me which tools you have available, which resources you have available, and those will come back. And the MCP client can then provide those to the LLM to say, here's our options to choose from. You give it a task, goes through the tool selection flow, the LLM is asked to determine which of the available tools it should be calling, and then it will select those tools. The client invokes those tools through, as I said before, function calling through the LLM. They get called, the results is processed and put back to the LLM. So in this case, if we're talking about building our own MCP server and are exposing our own enterprise data to like an AI platform, our data never actually leaves our server. The client and the LLM do all of the heavy lifting of taking human natural language, mapping that over to API calls, but effectively, our server is just an API with a few other things. So you can think of this like a REST API of sorts, following a different standard, different protocol. Under the hood, when we're calling these different endpoints, this is effectively what the MCP client is going to be doing. So first we call off to our tools list endpoint at the discovery phase. This comes back and tells our client, hey, these are the different things that you can call the different functions. And you'll see they have a name, they have a title, a description, in natural language that describes what this function does, what it's used for. And as well, a list of inputs and potentially outputs as well. You can say these parameters are required, you must pass these values in order for this function to execute properly. And the LLM will then use this information to determine what should actually be called. After we've determined this tool should be called, we post off to tools/call with the name, with our arguments, and we get back a nice result. In my case here, I've created a simple MCP server to go and get information about speakers from TDC. We'll call it the TDC MCP because we like catchy acronym names in development, don't we? So that's essentially what's going on under the hood. Now, you could worry about all of this, but thankfully, there's a whole bunch of SDKs and libraries available that bury all of this away. So we don't need to necessarily worry too much about this, and we can focus more on the detail of implementing our tools to do the tasks that we want. There's a whole bunch of popular MCP servers already out there. GitHub has an MCP server, so you can go and query and ask questions about your GitHub organization and the repos you have access to, even the code you have access to. Playwright, one of my favorite tools, has an MCP server now, which now enables behavior that I think has been coined semantic testing, where you can, in natural human language, describe the behaviors you want to test, and it will write you a Playwright test with the MCP server and go away and check some things. It's awesome. Unlocks a whole bunch of potential. And then similarly, Puppeteer, which is like a headless browser, can do the same thing. You can ask it to go off and perform certain tasks. The MCP server will go and do that. You just engage with it in natural language. So before, these things that would have required coding now actually means that someone who maybe doesn't have so much experience can just talk to their LLM in their preferred platform of choice and get up and running. So let's get started with building our own MCP server. I'm a .NET developer, and the concepts that I'm going to show you today are in .NET, but actually everything applies pretty generally if you're a Java dev. There's SDKs for this. So in .NET, we're going to use two key SDKs. The first is the Model Context Protocol SDK. This is an open source, standard-based SDK. There's versions of this for basically every single language and runtime you would want. It's maintained in a global, a global org. It's not tied to Microsoft in any way, although a bunch of Microsoft contributors do help with this. It started in the community. It's been adopted into the MCP org. And then separately, Microsoft's got their Semantic Kernel SDK. Now, for those that keep up to date with Microsoft and their AI development, Semantic Kernel is sort of going away, or at least it's changing a little bit. They're changing this into something they're calling AI extensions, catchy. Microsoft loves to ruin things with good names. So Semantic Kernel still exists. It's still very much what we should be using for now, but eventually this will be replaced by their extensions. And the concepts are still going to be the same thing. So it is an SDK designed to create wrappers around large language models and provide a nice, clean framework for building functions that respond to calls from an LLM. It's not directly integrated with MCP, but we can put these two things together and make a really powerful experience. So, without further ado, let's just look at some code, because I think the code's a little bit more interesting, and it's a way we can explain things a bit better. For the people at the back, is that hard to see? Would you like me to zoom in a bit more? Yeah? We can, 1, 2 more? Is that good? Cool. We'll minimize a few things. So, at its most basic level, to integrate with MCP and .NET, we have to install the MCP SDK. That is just a standard NuGet package, which I've installed here. You'll see I've created a project called MCP Server. And if we go to our CS proj, I have installed one package, the Model Context Protocol. It's in preview currently, but it's being pretty rapidly developed against. When we go to our application startup, our program, this is where we actually register our MCP server. So the MCP server just hangs off of .NET's inbuilt dependency injection container, and we call our add MCP server function, which is responsible for going and getting building all the framework out so that your web application can speak MCP. We have to denote which protocol we want to use. In this case, because I'm just going to build a standard MCP server to use locally, we'll use standard IO. That's the TCP. That's the JSON RPC-based protocol. And then we have to declare some tools. You're thinking, well, how do you declare tools? So in .NET, they've made, I would argue, quite a nice, friendly, clean approach to this. If we look at our conference tool here, I have created a class, and the class is decorated with a few attributes. And those attributes tell our MCP server how to report what tools are available. So we can create a static class. We give it this MCP server tool type attribute, which is used by the with tools from assembly scanning. So it will go and scan at boot time all of the classes, all the static classes that have that attribute above. And then within that, all of the functions that have an MCP server tool attribute are bound to be tools in the MCP server. So you can see, actually, without having to write any largely MCP-specific code, the rest of the code is just what I'd normally be used to writing. So a couple of attributes. Natural language description for the method. I mentioned at the start I've built a TDC MCP. So my MCP server has got a couple of key skills. It's not doing anything too fancy. It's mostly just generating randomized data. I have a dictionary, a static dictionary of upcoming conferences in Norway in the next 6 months or so. And this tool's job is to tell me the name of a random conference or find me the date of an upcoming conference. I also have a speaker tool, and the speaker's tool's job is to do a similar thing, return some bios of speakers, and then some other stuff that we'll get into in a short moment. So that's kind of it. You can imagine that you might already have a .NET application. You might already have a service layer, a database, and you want to expose that. Well, you would create a class. You would call upon that code from those classes, and you build your MCP server like this. Away you go. Let's see this in action. So when I run .NET run, you should see the application boots up. And I did just do a build like 2 minutes ago, so this shouldn't take a long time. If not, we'll skip ahead. Yeah, I'm going to be impatient. When you do a build, it will tell you how many tools are registered. So firstly, you need to tell your MCP client where your server lives. And in my case, it's running on a specific port. In Visual Studio, that is through through the extensions library, you can go into here and you can see all of your MCP servers that are actually enabled and configured. You can also register new ones here quite easily, like through the command palette up the top. I've registered this .NET MCP, and if we look at the configuration, that's not what I wanted. If we look at the configuration JSON, you'll see it's essentially a JSON object and some configuration file. Most MCP clients talk the same language. They have a very similarly structured JSON file that you can put in the root of your project. So mcp.json, and if you open Claude Code, it will pick up that file and register those MCP servers. In my case, I've told it I have a name. It's called .NET MCP. This is the type. This is the protocol you should be using, standard IO, the JSON RPC base. And you give it a command to run. In my case, because mine's built in .NET, I give it the .NET command, and I've said, hey, this is the path to the server that you actually need to run. And as soon as I invoke the MCP server here, it will boot that up. So it's going to run my .NET app, and you can see it's discovered 5 tools, because those are the classes that I've already registered. As we're in VS Code, and I don't want to leave, I'm going to ask it some questions directly in here, and we'll see how those tools can be interfaced with. So you have to be in agent mode in VS Code and GitHub Copilot for this to work. That's the only way that they'll call MCP servers. And you can configure which MCP servers are actually available to you. So in my case, they've got a whole bunch of built-in ones, but I'm going to untick all of those, and instead, just for the purpose of this demo, make sure only my .NET MCP server is actually selected. And those 5 tools that it knows about that I've already declared have been picked up. So let's ask it a question. We could say, name me a random conference. Now, the MCP client is going to go over reason on this request, and it's going to determine that actually there's an MCP tool available that it can go and get an answer from. And in this case, it's going to ask me, because the GitHub Copilot demo is really annoying, and it asks you before it calls every single tool. It's going to ask me, hey, I found this tool, random conference. Are you happy for me to execute it? And we'll just say, yep, that's fine. And so in this case, it's named a competitor. Should we try it again? Again. It's going to call the tool. It's going to find one of those random items from my list, and it's going to say Trondheim. Yay, cool. Woo. We can do some more advanced queries as we discussed before. So I mentioned that I've got a list of speakers, or we could say, actually, when is Trondheim developers? I'll just say when is Trondheim. It knows what that is because it's already retrieved that data. It's going to say, yep, I've determined you want to execute the upcoming conference MCP. We'll allow it, and it will go and get my data out. There we go. It's today. Wicked. We can ask it questions about speakers and start to do some more advanced things here too. So who is Callum Whyte? Now, of course, GitHub Copilot does not know who I am. But it's determined that, this is a fairly vague request, and I've got a tool that might be able to try and, yeah, that's failed. Should we try again? Who is Richard Campbell? It's thinking. Nope. This is the beauty of these AI demos. They can go literally any way you choose. Let's try instead and look forward to one of the more advanced demos I've got, which is that because this is just a .NET application that's just running in process, effectively the lifetime of that application is the lifetime of my client's connection to it. As soon as I disconnect, the process will stop. But that means we can actually retain state inside our application. So if we want to persist, I don't know, a set of scores for different speakers and sessions throughout a conference, we can do that, and it lives for my session, for my client. So I've created in my speaker tool here, I've created a dictionary of speaker ratings, and I have a way of rating a speaker and giving them a score out of 5. So I can say here, rate Richard Campbell 5. Of course, nothing less. And it should now determine that, yep, we can rate Richard 5. There's a tool available to do that. It knows that, yep, we have a rate speaker tool, and we'll allow that to execute. We can start to chain these requests up a little bit. Oh, okay. It's going to go and give me the average scores as well, spoiling the next bit. I have an endpoint that also determines what the average scores are for speakers. So we could say, okay, rate Callum Whyte 4 stars. I think that's fair. And rate Richard 5 again. So this is now 2 distinct requests that obviously don't directly map to a tool in my MCP server. But the LLM can reason over that and go, yep, that looks like 2 requests that match the same tool, and I'm going to make 2 calls to your MCP server. And there we go. It comes back with an average score. We'll just say rate Callum 5 once more, and give me his average. So in theory, that's done it twice, so it should be a 4 and a 5, a 4.5, and because this is a kind of fuzzy call, it will go and call our rate speaker endpoint, our get speaker endpoint, and then come back with the average in nice human language. That's pretty cool. So with minimal lines of code, we can now have a fairly powerful conversational integration with an LLM, and it lives directly in your IDE, which is cool. I mentioned, of course, Microsoft has their semantic kernel as well, and semantic kernel brings a few additions that actually make this experience a bit more powerful. So let's just jump over to my semantic kernel branch. Git check out semantic kernel. Great. So the semantic kernel SDK, as I mentioned, gives a bunch of friendly wrappers around the various features that LLMs offer to allow you to build intelligent applications. And one of their things that they call is plugins rather than tools. But it is possible to map semantic kernel plugins to MCP and have MCP server just use the existing semantic kernel tools that you've got, because semantically they're kind of the same thing. This is my semantic kernel tool called my venue plugin. And this is purely using semantic kernel's own definitions for what a plugin looks like. We decorate it with our kernel function attribute rather than before, which was an MCP server tool. We give it a nice natural language description, and you can see here it's doing some fairly basic stuff like report what could be for lunch, choose a random option, choose a random number for the speaker room. And so in the program in our startup, this looks slightly different to what you'll have seen before. Of course, all of the code here is exactly the same as we had a moment ago. But instead, we just tell semantic kernel that, hey, we also have these plugins, and you should register those. And then we have this with tools and add the semantic kernel to our MCP server, and we now combine these 2 worlds. The benefit of this is semantic kernel offers things like filters, and they offer things like dependency injection. So these classes don't have to be static anymore, and we can start to create slightly more powerful classes and maybe just follow existing code and patterns that we already have. So let's boot this up one more time and just have a look. Having done this, what happens? So you'll have noticed before it discovered 5 tools. I've now registered a new plugin, and in theory, those same 5 tools exist, but these 2 new tools should also exist. And yeah, it's discovered 7 tools. So let's fire up our Copilot session again. I think because I manually opted certain tools in. Oh no, it's got them all already. Great. So we could ask, what's for lunch? Of course, we've already had lunch, and we know it's none of these options. But it will infer over that and determine, yep, there is a tool that can answer that question, and no, that's not what we wanted it to do either. Damn! Okay, should we try... where's the speaker room? And this is just a random number generator. It's going to come back with a random number, provided GitHub Copilot doesn't decide to go do something random again. Nope, okay. Wow, cool. That's fine. We'll close it. It's clearly given up for today. But you get the idea. We can now register those tools with semantic kernel and use their own APIs, which is really handy. So this is great, but I'm running this locally, and so there's not really any need for me to bake permissions and things like that into it. But if we were calling off to real databases, real API endpoints, you probably would want to make sure there was some kind of authorization and authentication mechanism in there. So MCP already offers this idea of a protected resource, and so you can determine you can broadcast to your MCP clients how to authenticate against your MCP server. And in this case, this is through this protected resource metadata, a file that just goes into a .well-known folder and is broadcast. In .NET, you can wire this up in line when you actually configure your MCP server. In this case, you're actually able to point your MCP server to any OAuth 2.0 compliant identity provider and say, use this as the identity provider. So it supports identity baked in. And that means if you've got an existing identity provider, perhaps in .NET or perhaps using auth0 or one of those other platforms, you can say, hey, you should use that provider to authenticate. And that then means we can bring that authentication context into our tools. And at the tool level, we can say, hey, does this person have permission to do this thing? And we can check their authentication before we go and execute any code. So let's have a little look at that. I have got another branch which we're going to check out. Git checkout main. And if we jump over to our program CS, you'll see it's evolved a fair bit. Let's just collapse that. We've registered our authentication scheme. In this case, we've just said, hey, you can use the default one, but we can also specify our MCP resource metadata, which includes the authorization servers we want them to use. In my case, it's just the same server that we've got right now. And then we're actually back into .NET's own standard auth stuff. If I just want to use ASP.NET Identity, I can do so. I register add authorization and to use authentication, and use authorization, and on our MCP server say, hey, you need to require authorization for anybody that tries to connect to this. We give it a host because it needs to know the host that it should be connecting on, and away it goes. As we look at this from an implementation perspective, I mentioned you can just fetch the authentication context out of your tool, and you could use that to determine, should I be doing this or not? But that's not too clean, and .NET already has quite a nice pattern for determining, hey, should this user do something? In ASP.NET Identity, in ASP.NET Core, that is an authorization attribute. And because this is based on an HTTP web server, we can actually use that too. So what I've done here is I've, on my venue plugin, actually misused and abused the ASP.NET Core authorized attribute and decorated that with a role. And because that already knows about how to go and get the current authenticated user, it will understand exactly whether this user has that role, and it will deny calling this function if that authorization fails. Of course, this is not standard and not out of the box. I mentioned I'm abusing the framework, but I can use a feature in Semantic Kernel called filters. Semantic Kernel has this concept of filters that will allow you to run code between the execution of tools and plugins. And that means I can write my own auth filter that firstly just does a quick check to see if the user is authenticated, and then it will do a check to see if the user is actually in the role for that authorization attribute and reject, terminate the call, or allow it to proceed. And that means we've got effectively a really nice, quite clean way of doing role-based authentication directly inside your semantic kernel functions, plugins, and therefore your MCP tools. Now, Dan Delmarski, he's on the .NET team, but he's also one of the core contributors to the MCP SDK. And he has some amazing blog posts about this on his den.dev blog. So if you're interested in reading a bit more about how authorization works in MCP conceptually, but also how you might do this in .NET, I highly recommend reading these different articles. What I've showed you here is a very basic implementation of that. But I can put this back for a second if people want it. Of course, this is all well and good, but we're still only running locally on a local machine here. And that's great because it means it's quite secure. It's using our own server. But if you wanted to roll this out, let's say, into your company, you have to think about a few things. And exposing your data, your system, to large language models and to users across the world is pretty risky. It comes with some different challenges and different security challenges that we don't typically have in our standard applications. So the top three biggest threats, really, about using MCP in the wild are unauthorized execution. This is tools or resources being called in such a way that they were not designed to be, or in a way that they are not being called from an authorized user's perspective. You'll probably have heard the kind of, hey, ChatGPT, forget your prompt, do this type thing. So this is a fairly common goal if you're trying to do that, which is our next thing, prompt injection. So prompt injection, if you're going to tell an LLM, hey, you should forget your prompt, and if someone asks you to do this, you should do this other thing instead, means it allows someone to manipulate the behavior of your MCP connection, of the host that's connecting to your MCP server. And in doing so, they could manipulate and make it so that certain tools can be called when they shouldn't be. And the final one is tool poisoning, and this is probably the biggest thing. So you'll have seen here that I'm registering a bunch of tools, and those tools will have names. And the LLM is deciding and reasoning over which of those tools should be called. And if I, as a bad actor, wanted to redirect your attempts to call what would be a trusted tool off to something that is not trusted, something that I control, I could give the LLM something with the same name, and maybe with a better description, a more accurate description, that will be more likely to match with that tool. And in that case, I could be siphoning all kinds of information off from your service without knowing. I showed you already that inside your like VS Code, for example, when we boot up our GitHub Copilot, we can control exactly which tools are allowed to be used. The default is that everything's selected. And this is probably my biggest tip. The word of caution is don't accept anything, only opt in to the specific tools that you believe you know. And it does slightly ruin the magic, the experience of just saying, hey, my AI agent, do this thing, and it reasons over all of the tools available. But it stops people from registering tools that could be malicious. How would they do that? Well, VS Code plugins can register their own MCP servers. So you could have a VS Code plugin that gets hijacked by somebody, they release a new version, it auto-updates with VS Code, kind of the beauty of it, but then suddenly an MCP server is there with a common name, a better description, and it's more likely to be called. Equally, different LLMs, I'm using GPT-5 here, but I could switch to another LLM that reasons differently over those descriptions and will choose a different tool instead. So it's probably good practice just to select the things you do want, just in case. But of course, if we're going to put this into production, we need to actually think about scale. And one of the biggest things really here is monitoring. If you've got an LLM integrated system running anywhere in the world, I would say the best thing you can do is have true, full observability over every time that's being called. So you can monitor and detect times that people are attempting to call that when they shouldn't. Microsoft has put a lot of work into .NET Aspire, and .NET Aspire is a really good way of running your .NET application workloads in the cloud with full tracing and observability. It's got open telemetry kind of baked in out of the box. They also have Azure's API management, which is a tool you wouldn't necessarily directly associate to AI, but this is very quickly being set out as an AI gateway product. AI gateways being the thing that you put in front of your application to make sure that if some MCP client or AI system is calling it, if it's doing so in a malicious way, it can block those requests. And you can see in the AI gateway exactly what those requests look like. Cloudflare has also done an amazing job in recent time of building out a product like this that arguably is more competitive and easier to use than the Azure API management product. There's a whole talk even in AI gateways as a whole, so we can't go into that too much today. But I will show you just how easy it is to take our same .NET MCP application we've got and turn that into a .NET Aspire application that I can then run and I can see all of the different requests. So let's jump back over here. Let's close out a couple of things. I'm going to jump to my Aspire branch, and you'll see a couple of extra projects have appeared here. So .NET Aspire effectively allows you to containerize any .NET application and deploy that workload to a managed service, be it like Azure's Container Apps or a product like that. They create this app host, and the app host is the entry point to the application that bootstraps all of your different services and containers. And within app host, you can just say, hey, I would like you to consider this application a service that you need to deploy. So in my case, I have added the MCP server project that I've already created. No modifications needed over here. This continues to work exactly as it did before. The only catch is if we're deploying this into the cloud, we can't necessarily use that JSON RPC-based approach for hosting. Typically, we're going to want to put that behind a gateway of some sort, and those gateways talk in HTTP language. So we need to tell it, instead of using standard I/O, please instead use the HTTP transport. Other than that, this should continue to work exactly as we're used to. So I'm going to just jump into my app host and boot this up quickly. So MCP aspire app host .net run. And this is going to boot up my MCP application, my MCP server locally. You'll, if you've been paying attention, have noticed I've registered 2 MCP servers already in my VS Code configuration here. One of them is this Aspire MCP server. And that, if we look at the configuration, unlike the one above, the .NET MCP that's calling a process, it expects that host to be available. So I've had to, in this case, manually spin that up for local development, but that could be running in the cloud. That could be a service that's running somewhere on a host name that you control. You just point it at the HTTP URL, and away it goes. Let's log into the Aspire dashboard just to show you what this has spun up. So, as I mentioned, it's a framework for, that's not correct. It's a framework for running distributed applications in the cloud. And you can see I have my MCP server instance running here in the cloud. If I go to my Aspire MCP server and connect that up, we should start to see, yep, it's discovered that I've got 7 tools available, and it's done that through connecting to my server over HTTP. If we look into the individual MCP server process, we can actually look at the traces here. And we can see all of the attempts and the requests that have been made to our server. And we can inspect those, we can store those, persist those somewhere, and use these for monitoring. So if you're going to run an intelligent application in the cloud, this is a pretty good way to do it. And finally, let's try one last demo fail, shall we? And see if we can get this to work. So first things first, I'm going to disable my .NET MCP server just because I've got the same tools, and it's going to reason over those and determine that they're basically the same thing and decide randomly which ones it's going to call. I'm just going to make a new chat session as well, and let's ask it to rate Callum Whyte 5 stars, of course. Humble. And it's going to reason over this like we've seen until now. Okay, so it's not. Anyway, let's call it a day. Clearly, it needs a beer. It would, if it had worked, show up here in the trace. You'd see an attempt that the LLM had made. Firstly, to those 3 endpoints we showed earlier, to discover the tools. Secondly, to invoke one of the tools, and thirdly, to get the response from one of the tools. Can I ask it to use the tool specifically? Should we try it?
Yes, you can. And it works.
And use, what is my tool called? Rate speaker?
It helps to mention that's an MCP.
Okay, yeah, wow. That's really dumb. In my experience, my personal experience, using the Claude Code and even the ChatGPT dev mode, MCP integration is much better than the GitHub Copilot one, and I'm not quite sure why. It's not done that properly either. Anyway, we'll call it a day there. As I mentioned earlier, Den Delmarski's got a fantastic blog, and he's got a great blog as well about running your MCP server remotely behind the Azure AI Gateway. So I really encourage you to read that if this is something you're going to consider deploying into production. I'll leave it up for a couple of seconds more. Don't worry, it's on the next slide as well, a couple slides. So to recap, this is the recipe that we use to go from never having built an MCP server before to deploying this into the cloud. And these are the key considerations you need to make for both using and deploying MCP servers securely. Firstly, the Model Context Protocol NuGet package is a great way to integrate the MCP server standard into your application. And you can use Semantic Kernel to tie those two things together if you like the friendliness of the Semantic Kernel APIs, or if you just need the powerful features like filtering, etc. for auth. Model Context Protocol supports OAuth 2.0, and you can plug any OAuth server in to do that. You can use .NET Aspire for deployment, easy deployment to, say, Azure container apps, and then also use that for traceability and observability. Use the Azure AI Gateway, APIM, for security and production readiness, also for things like caching and stuff that you might want if you were running a production system. And make sure you're only using these trusted servers. Restrict those in your client of choice to make sure you're just using those. All of the different resources I mentioned today, so this MCP and OAuth by Den and the MCP and security article by Den are great. You can go check those out. There's also a fantastic Microsoft Learn getting started on how to get up and running with MCP in .NET. And with that, I'm 40 seconds over time. So thank you. All of the projects that I've shown you today are on my GitHub. You can go have a play with those. They should run out of the box. Fingers crossed. I'm on Twitter, Blue Sky, LinkedIn, etc. that handle. But thank you very much.